All right, so when the tokenized list arrives at syntax analysis stage and checked for the grammatical rules of that particular language, it is called what? Parsing. The whole program goes through this process even if errors are found. That is the property of the compiler. It doesn't stop, it goes on even if there are errors. The rules for parsing can be set out in Backus-Naur form. And the way we wrote this Backus-Naur form, this is called Backus-Naur form notation. If any errors are found, each statement and associated errors are output, but in the next stage of compilation, code generation will not be attempted. If there are any errors at this stage of the compilation, code generation for the next stage will not be attempted. And if there will be no errors at this stage, then the code generation will happen. The compilation process will finish after this stage. If the tokenized code is error-free, it will be passed to the next stage of compilation, which is generating the object code. All right. So you should understand, yesterday I told you that there are three main stages. First is the source code generation. When source code is given to the compiler, it tokenizes it. Tokenized goes to lexical analysis, syntax analysis, and after syntax analysis it enters the second major stage, which is called intermediate language. And from that point onwards, it goes for code generation, and after code generation it is optimized, and the third major stage arrives, that is the object code generation. So before we go any further, there is another thing which is called semantic analysis. This semantic analysis is about, if you have paid attention to previous lectures, you would already know that at lexical analysis we check words. At syntax analysis, at parsing stage, we check whole sentences for the grammatical rules. And at semantic analysis, which is also the part of parsing, what basically happens, anything which goes beyond the limit of one sentence or one line is being checked. For example, if there is an associated and if found for every if there is an associated and for or next is found for every for, and there is another thing. If you do remember from your assembly language, sometimes we refer to symbols. When we refer to symbols or we refer to a memory address, which is not this particular line where the program is executing the code, in that case we are referring to something which is beyond this line. That thing may be present or may not be present. Sometimes you mistakenly type the name of the symbol or variable, and that there is a possibility that variable name is all right, the syntax is all right, but that particular variable is not found. So such things can be checked at semantic analysis, but at semantics analysis, it is more important to understand that the semantic analysis is actually checking the formation of the block, if and if, for, next, while and while, start program and program, as in start module and module, procedure and procedure, things like that. All right. And sometimes you write statements to kick the program execution out of the loop, like exit for. So exit for is a single statement that can be written anywhere, but it is supposed to be written inside a for block. All right. So such things are actually checked at the semantic analysis stage. All right. So source code is fed to lexical analysis. Lexical analysis tokenizes it. Tokens goes for parsing. After parsing, if there are errors, system does not enter the second stage, but put all the errors over the screen. All right. Sometimes we call it diagnosis, the diagnostics, when the system give all the errors over the screen in compilation. If there are no errors, its system enters the next stage, which is called code generation. All right. So intermediate language or intermediate stage is a position where all physical non-runtime or runtime errors or non-logical errors are removed. Runtime errors are those, or logical errors are those, which basically appear when the program is being executed. Code might be written correctly, but you might have made a logical mistake or a mistake which is not letting you see what you were expecting. Such type of errors which do not let the program stop, but they produce wrong errors, are not physical errors. Physical errors are the grammatical errors. Okay, the code generation stage produces an object code to perform the task defined in the source code. The program must be syntactically correct for an object program to be produced. Means this intermediate language stage must be passed through without any error. It is no longer in the form that is designed to be read by humans. This object program is either in the machine code, which is binary, that can be executed by the CPU, or in an intermediate form that is converted to machine code when the program is loaded. So this intermediate language form is actually the object code. All right. So the object code is in the form of the machine code, or in an intermediate form that is converted to machine code. Intermediate form which is converted to machine code when the program is loaded. So this intermediate option allows greater flexibility. Okay, so there might be few compilers at this stage. You need to understand that there might be few compilers which generate the object code in the form of machine code after parsing. All right, but if it is intermediate stage or intermediate language or intermediate uh, form that is converted to machine code later, then in that case it is flexible and code generation happens. Intermediate code can support the use of relocatable code so that the program can be stored anywhere in the main memory. As we know that when the program is executed, it is not necessarily be loaded by the operating system every time it is executed at the same position or location in the memory, it will be loaded in the memory as per the situation of the computer's memory at that particular time. Hundreds of thousands of people are running software all the times in their cell phone, in the desktops, laptops, and tabs. So what operating system does, it finds the space on the go. Few people might have a lot of memory available for their computing machines, few would not have. So operating system goes through a lot of effort to find enough space in the RAM. That is part of another topic later, and then loads the program. So this flexibility in loading the program at the available stage is actually given by this intermediate form or the language stage. Secondly, the addition of library routine. You see, when you write the program, you call a lot of um, procedures and functions, or maybe other programs while your program is being executed. Your program, when you write functions. What are functions? Functions are already written routines. They might be written by you, or they might be already made available, like whatever that you have done in AS with respect to, let's say, string functions. All those functions are made available by the programming language itself, but they are written somewhere. All right, so when the program is being executed, those written modules are called and they are combined with your code so that so that those could be executed alongside your code. If those functions are not being executed, what is the purpose of your program? When you write your program, using those functions. So those functions require to be connected to your program. All right, so those functions, their collection is actually called library. So we will be studying library routines later when we will be studying operating system. At the moment, we just remember library routines as the collection of all the functions and procedures available made through the programming language or by someone else, but not you. And you are using it in your program. So the addition of library routines to the code at this stage to minimize the size of the stored object program. Now there are two types. Few of the compilers, what they do, they just call those functions when they are required from other library routines. Or few of the compilers, what they do, they just call them and combine with your object code. So if those functions are being called and they are combined or binded with your code so that your code is working properly, in that case, the size of the code will be uh, enlarged. That would be fattened. So sometimes what they do, they actually keep those library routines separate, as you might have heard of Java Beans or uh, .NET in Microsoft. Those are the library routines. So sometimes when we, especially when we install games and all, sometimes few of the games require .NET library. What does it mean? It means that that library must be present so that when the game is being executed and calling the functions from that library, they are made available right away. All right. So games themselves are large software. So if they are large software themselves, having that library binded with that will make it further large. So what they expect that the user would have that library separately installed. And that library is not just being used by those games, but in the Windows operating system, many of the programs are making use of those libraries. So keeping those libraries alongside that program and letting the program, when it is being executed, to make use of those libraries is actually the part of compilation processes output. So that is basically done by a part of the operating system which is called linker, that links, all right, that links external library routines with your program on the go. All right, so what I said, that intermediate code which is written at this in this flow of the program in the middle, if it is made before the machine code, it would have flexibility. And what is that flexibility? It supports the use of relocatable code in the computer's code, so that the computer program can be stored anywhere in the available memory. Secondly, I said the addition of the library routines to the code at this stage to minimize the size of the object program. Thirdly, the linking of several programs so that they could get execute together. So at code generation, what basically happens, that system makes use of binary trees and TAC. Let's do that. Binary trees and TAC, three address code. TAC or binary tree. I would not go into much of the detail as that is not required, but over here what happens, as you would have seen in reverse Polish notation lecture, that when the statement is written like X is equal to A plus B, it is converted to the binary tree form. All right. Okay, it is converted to binary tree form. And then it is being used. Or there is another thing. Achha, this might happen with anything else, but we are actually trying to understand this, that at this particular stage, at the code generation stage, the system makes use of binary trees to generate the machine code, or it makes use of, after binary trees, it makes use of TAC, three address code. It is called TAC, three address code. Now, what does it mean, three address code? I think after studying assembly language, computer architecture, and conversion from denary to binary, and how computer keeps binary, and knowing floating point numbers, you would have this idea already that the computer at the basic stage where it makes this data useful for itself is very simple machine. So whatever that you do that is in human terms is complicated for the machine. So what machine does, what is this whole compilation, what is this whole assembly language, what is this whole machine code, or at architecture level, what is this all registers and all? If you see that these are simple things. So the process of from what we understand with these complex brains, with the quantum computing that God has given to us, to the level where this machine in the architecture at the register level, it is nothing but the simplification of what we do in human terms, simple tasks. For computer it is complex tasks, to be made available for the computer in those little chunks of binary. So basically what happens, that the whole effort is put to break the things, the tasks that we require computer to do in little and so many different statements that could be understood by the computer. So that breaking of the complex thing to this simple level, simplification, is done because at the root level, the computer itself is a simple machine. Let's take the operation, arithmetic operations. So computer cannot do anything other than addition. So for the sake of subtraction, we make use of 2's complement. So what basically happens, the number which is being subtracted, we convert it to 2's complement and add it. When we like to do multiplication, we know that multiplication is actually the short for the addition. So we add it. When we try to do division, we know that division is basically is a short for subtraction, and subtraction is done with the help of 2's complement addition. So what is happening? Addition. So things are being simplified for computer. Similarly, few of the machines, for your syllabus sake, let's understand this, that they cannot handle at the architecture level. You can go to Wikipedia and try to understand it, that at architecture level, the computer cannot handle more than 3 addresses in the memory in one statement. Computer cannot handle more than 3 addresses. What those 3 addresses are, they might be 3 variables as I have written over here, x is equal to a plus b. They might be 3 symbols from assembly language, or any other way. Computer cannot handle more than 3 addresses in the memory. You see, this code generation thing, this code generation requires you to put the statement or the data or whatever that you have produced in the form which can be not just understood by the computer, but is in the form that is actually can be taken by the hardware of that computer. So I told you that this hardware cannot handle, this is a physical problem, that this hardware cannot handle more than 3 addresses. This processor is made that way. So compiler tries to break a larger expression in the form which can be easily understood by the computer in terms of 3 address codes. All right, so that is how it works. So let's check it or the website so that you could properly understand it. So code generation, it is at this stage when all the errors due to incorrect use of language have been removed, that the program is translated into code suitable for use by the computer's processor. During lexical and syntax analysis, a table of variables has been built up, which includes detail of the variable names, its types, and the block in which it is valid. The address of the variable is now calculated and stored in the symbol table. Now means at this code generation stage, as I told you that this gives us the flexibility at this stage. It gives us the flexibility to load the program anywhere. When you load the program anywhere, all the related code and the variable addresses will be changed. So this is done at this particular stage. This is done as soon as the variable is encountered during the code generation. All right. So now, before the final code be generated, an intermediate code is produced. This intermediate code can then be interpreted or translated into the machine code. In later case, the code can be saved and distributed to computer system as an executable program, the machine code. Two methods can be used to represent the high-level language in machine code. This syllabus does not require knowledge of either of these methods, but a brief outline is given for those who may be interested. But do not pay attention to this last sentence. All right, so take it like we have to do it anyway. All right. One uses a tree structure and the other uses tree address code, TAC. The TAC allows no more than 3 operands. So operand 1 equal to operand 2 and then one single operator and then operand 3. So basically what happened? Let's say we have got this particular expression written in the source code. So this expression requires us to have 1 address, 2 address, 3, 4, 5, 6. So you should understand it this way, that every particular variable is actually stored at one memory location. That one single memory location is being treated as one address. So we have to have 1, 2, 3, 4, 5, 6 addresses. Computer cannot handle these 6 addresses. So we have to break it down. So this would be like R1 is equal to B plus C, R2 is equal to D minus E, R3 is equal to R1 multiply with R2, and A is equal to R3 divided by F. So get the idea. So do not pay attention to this last sentence that it is not required by the syllabus. This might appear that you might be given a larger statement and you would have to actually break it in the form that every single stage is having only 3 addresses, and when we solve it one by one, we would have at every stage 3 addresses, and ultimately the whole solution can be found. So it is part of the simplification from the complex statement to the simplified that could be understood by the computer. It can be executed by the computer at one stage in one cycle. So get the idea. So you might be given a larger statement. You might be said that 3 address code के साथ इसको जो है वो आप break करें, simplify करें, तो करना होगा. All right, so that can still be seen this way. This is actually the binary tree, as I explained, that this is B plus C and then D minus C. They are being multiplied, and then this is being divided by F, and then it is being assigned to A. All right, so that can also be represented in a tree format below, not below, above. So get the idea. So this is actually the code generation. Okay, so at code generation, the machine code is being produced, and it can be, I was just checking in the book, there was a question that at what stage tree data structure is being used. So you would have to tell that at code generation. All right, so mind it. So 3 address code, you have to keep that in your mind. So other statements can be represented in similar ways, and the final stage of compilation can then take place. The compiler has to consider at this point the type of the code that is required. Code can be improved in order to increase the speed of execution or in order to make the size of the program as small as possible. Often, compilers try to compromise between the two, the size and the speed of execution. This process of improving the code is called code optimization. The optimization stage starts. The optimization stage supports the creation of an efficient object code or object program. Optimized programs should perform the task using the minimum amount of resources. These include time, storage space, memory, and the processor's use, the CPU use. Some optimization can take place after the syntax analysis or as part of the code generation. All right, so object code is sort of assembly language code, and machine code is basically, let me show it to you. So get the idea. So if we have got a larger equation like A plus B minus C multiply D, and then we have got X is equal to. All right, so we be like N is equal to A plus B, M is equal to C multiply D, and then X is equal to n minus m. So this is actually 3 address code or tag. Hold on for a moment. So after code generation, code optimization happens. Code optimization. Okay, at code optimization, let's say I want to show you that how the original code that we write, let's say we write w is equal to x plus y, w is equal to x plus y. So what will be the object code? Object code would be something like load x, add y, load x and y, you should understand them like they are symbols, and then we store it at w. And equivalent machine code would be something like 0, 0, 1, 1, 0, 0, 1, 1, something like this. All right, so get the idea. So this is object code which is being generated as per the language, and then the machine code is being generated. So you should get the idea. Afterwards, the code optimization happens. Optimized code, let's say we have got, let's say we have got this original code, which is something like this. This is the source code, let's say. W is equal to x plus y, and then v is equal to x plus y plus z. All right. V is equal to x plus y plus z. What you have to actually observe that x plus y is being used twice. So making the processor do the same thing again. All right. So as far as ourself is concerned, we don't care about it, because whatever the x is y, we can do it again and again, and we can understand that computer can do it again and again as well. So the object code of this particular code would be load x, this is for w, load x, add y, store at w. This is for the first code. Afterwards, for the v, load x again, add y, then add Z, and then store at V. So this is actually from original code to object code, which happens to be the assembly code. Now what we need to do, we have to optimize it. How do we optimize it? Let's first see that optimization in original code form. Let's say we will write W is equal to X plus Y, and then V is equal to W plus Z. This will exactly produce the same code as of this code, but we don't realize it when we actually write the computer program. So let's suppose that this was converted to the object code and then it is being optimized. So optimization will actually remove this load X, add Y. All right. So what will happen? This would be load X, add Y, store at W, then add Z to it, and then store at V. So see what we have done. We have optimized the code for how many lines? These are 1, 2, 3, 4, 5, 6, 7 instructions, and these are 1, 2, 3, 4, 5 instructions. So we have optimized the code for 2 instructions. So whatever that is happening again and again, we have eliminated it. The addition XY is only performed now once. And the second addition can make use of the value W stored in the accumulator already. This optimization can only work if the 2 lines of the codes are together in this order in this particular program. All right. The task of code optimization is one of the most challenging stages of the compilation. Not every compiler is able to optimize the object code produced for every source code program. You see, this is directly related to the human intelligence. So whatever humans do, computer not necessarily can understand everything. So sometimes computer may conceive it wrongly. So computer does optimize, but to the level which is basically in control of the computer. So let's get back to the website. Sir, W को वापस LED भी नहीं करेंगे. W को वापस LED नहीं करेंगे. Yes, W would not be loaded again, because when you load X, add to Y and store at W. So what you have stored at W, whatever that is in accumulator. So it is already in accumulator. So W is already in accumulator. So you just add Z to it, and then whatever the result, you will save it to V. All right, so we were going to the website. So another example of code optimization is shown below, where the code on the left has been changed so that on the right, let's just first observe it. So this is not in the form of code, this is in the form of mathematical expressions. So A is equal to 5 plus 3, B is equal to 5 into 3, R1 is equal to A plus B, R2 is equal to R1 minus B, R3 is equal to R2 divided by A. R4 is equal to R1 minus B. So you can see that R2 is equal to R1 minus B and R4 is equal to R1 minus B. They are both doing the same stuff, both R2 and R4. Then R4 is being used in R5, R5 is equal to R4 plus 6 and C is equal to R3 minus R5. So what we have to do, we can optimize this R4 thing. So we can replace this R1 minus B with R2. But that replacement over here will actually lead to a problem, and that problem is 3 address code. So this is not 3 address code anymore. This is 2 address code. So computer has to have 3 address code. So what we will do, we will ultimately remove this R4. And wherever the R4 is being used, we will use directly R2 because R4 and R2 are basically doing the same. So we will remove this line, and instead of R4 over here, we will use what? R2. So we have optimized for one line over here. All right, so such challenges may appear in exam at any given time. So you just be mindful about it. So what is optimization? Optimization is about about finding the balance between the size of the code and the time of execution. I told you what were the factors for code optimizations. Code optimization factors are those factors were time, after time it is storage space, after space it is memory and CPU use. So there might be three types of question. What is optimization? Optimization is when the object code is generated, it is being evaluated if it could be further shortened. If there are any redundancies in the code, redundancy means what you have done once, you are doing it again and again. So those are eliminated. All right, so code is optimized. Code is optimized for speed, means the time. Storage space, so that it could be produced, the machine code is produced in as little space as possible. And then when the program is being executed, it is taking less RAM, the memory, and the processor's time. Obviously, if there are many instructions, the processor will be engaged for long. And if there are less instruction, it will be engaged for less. So this was code optimization. So in a way, we have completed it. We have completed stages in compilation. All right, we have completed stages in the compilation of the program. So now you know the whole process, and afterwards, let's just see the syllabus. What it says further, or we have completed it or not. So let me share it. Show understanding of how an interpreter can execute programs without producing a translated version. This we have discussed earlier. Show understanding of the various stages in the compilation. We discussed lexical analysis, syntax analysis, code generation, and optimization today. Show understanding of how the grammar of the language can be expressed using syntax diagram or Backus-Naur form notations. We discussed it today. Show understanding of how reverse Polish notation can be used to carry out the evaluation of expression. So this particular 3.4.3 is completed. Let's solve few of the past paper questions. Check if the library routine is present or not. So you see, you need to understand that many of the things when we are reading books or notes are not very much clear. So you have to be very much clear that what happens at lexical analysis stage and what happens at syntax analysis stage. At lexical analysis stage, we check words, we make use of keyword tables, we create simple tables, and all the words are being tokenized, all right? And at the compilation stage, grammar is checked, error diagnostics are issued. What are error diagnostics? Any of the errors which are found are put to the screen, are showed over the screen. Jump destinations are checked, so it means that it is now what? It is now semantic analysis. I said that any of the checkup that is beyond the sentence or statement is basically what? The semantic. So jump destinations are checked. So if you have made your program to jump somewhere, remember JPN, JPE, JMP, those instructions, those locations are checked if they are found or not. That control construct. So if has and if, for has, next, if while has and while, and things like that. Then check if the variable is declared. So if there is a token coming from symbol table, that means that it's a variable or it's a constant, so whether they are declared or not. Few of the languages that do not require declaration, like Python, so that is a check which is not happening in Python. But if it is a language where the declaration is necessary, like what happens at the level when we do programming in Visual Basic, वहाँ पर फिर हमें उसकी ज़रूरत पड़ती है. Check if the library routine means all the functions and procedure that we have called, if they are present or not. And May-June 2004, describe what happens during the syntax analysis stage of the compilation. We have already covered it. Variable name is defined in a particular language as an alphabetic character. We did it yesterday, so we just move on with this. Explain what happens during the lexical analysis of a stage of compilation. We have covered it. Describe two things that happen during the code generation. Now, this is May-June 2005, P3, Part C. Describe two things that happen during the code generation. So code generation, what we have discussed at code generation, we mix the program becomes flexible so that we could load it anywhere in the memory. So if we are loading it in any of the memory location, it means that we are calculating the addresses where we can load the program. So address of the variables and the program statements are calculated. So address of the variables which require to be loaded in the memory are calculated so that they could be loaded over here. And these addresses are then added to these calculated addresses are loaded to the symbol table. All right. And then we have got what? Intermediate code is used, or sometimes it is produced. Then we have got what? Number 4. Intermediate code is converted to machine code. And during this code optimization, after this after this code generation, code optimization is also happening at code generation stage. So the code optimization is part of the code generation. Code optimization happens. Code optimization is done. And then what we have, that's about it. That's about it. Okay. So mind these all things. What we are actually solving now is basically sometimes the addition to what we have just learned. So please take notes of it. So explain how errors in the reserved word and variables are found. This is May, June 2006. Explain how errors in the reserved words and variables and used in high-level language instructions are recognized by the translator program. So if these are reserved words and variables, how we know that what are reserved words? Reserved words are the words which are given by the language. So let's say if we have got one statement, dim a as integer. So dim as integer. These three are reserved words because they are given by the language to us, and a that we have chosen it is basically the variable. So what basically happens that the translator program maintains a dictionary of the reserved words in the keyword table. If the reserved word use is not in that keyword table, then an error is generated. All right. Messages may be given which suggest one of the spelling. That means that if you might have made a spelling mistake. All right. So messages are thrown over the screen so that you have an idea. So if it is a spelling mistake, you can correct it. All right, so reserved words are in the keyword table. Every word is being checked against that keyword table. If it is found in the keyword table, it is good. If it is not found, there are two possibilities. Either that reserved word would go to symbol table, or sometimes errors are generated. So spell mistakes are removed at the stage of lexical analysis. Then we have got what? Variables. Variable name must follow the rules of the language. You remember variable naming convention. Those naming conventions are basically checked at this stage, which is lexical analysis. Translators or compiler tries the rules against the names and reports any error. Okay. Now, whatever that you assign to the variable, for example, if it is integer, we cannot assign, if it is integer, we cannot assign Zafar Ali Khan to it, since it is integer. So this assignment is basically wrong. We cannot assign a different type of data. So content of the variables must be checked at this stage. They must be of a specific type. Error created by the attempted use of anything else is at this basically stage. So this question was actually a generalized question, that what happens when there are errors in high level language, when we make these errors in reserved words or the variables. So reserved words are checked against the keyword table, and if they are not found in it, they are actually put in the symbol table by some of the compilers. If these compilers are made other way, so then in that case reserved words will be, if reserved words are not found in the reserved word table, then they will be treated as the error. Variables, variable naming conventions are checked, variables assignments are checked, variables names are checked, and the assignment, sorry, the literals which are being assigned to the variables, they are checked. They must be of the specific type of that particular variable. Now, October, November 2006, explain the purpose of code generation phase of compilation, including the principle of optimization. We have just done it. Describe how a variable in a high-level language program is dealt by the compiler. This is October, November 2007. October, November 2007. Describe how a variable in a high-level language is dealt with by the compiler. Variable name is added, obviously variable name is added to the symbol table. During the lexical analysis, a token is generated and it is passed on to the lexical analysis. So let's just, so what basically happens, it is added to the symbol table, then token is generated. Which stage is this? This is lexical analysis. All right. Then data type is added. Data type of this particular variable is added to the symbol table. Scope of the variable is added as well. These two things happen at syntax analysis stage. Okay, these two things happen at the syntax analysis stage. Then we have variable names. We just discussed that variable names are checked for the naming conventions. This is, which stage is this? This is code generation stage. Then variable locations or addresses are calculated or hashed and added to symbol table. So this was code generation. I don't remember anything else. So this is what is happening with the variables. This was the question. This is the answer. This was 6 marks answer, so you would have to be very much clear about it. Describe how the variable in a high-level language program is dealt by the compiler. So at lexical analysis, it is added to the symbol table, token is generated. At syntax analysis, data type is added to the symbol table, scope is added as well. Scope, you know, local global scope. And at code generation, variable names are checked for the naming conventions, if they are named as per the rules of the languages or not. And then variable locations and addresses are calculated or hashed and they are added to the symbol table at code generation. So this was your answer. Describe how a compiler recognizes a syntax error by using May June 2008. Describe how a compiler recognizes a syntax error. I skipped this question because we have completed it yesterday. Okay, so May June 2008 P3. Describe how a compiler recognizes a syntax error. May June 2008 P3. Reserved words are checked, and if they are not present in the reserve table, reserve word or keyword table, an error is generated. If the reserve word is identified, then uh, then syntax is checked. How we can explain it, since they actually require us to recognize a syntax error. So syntax error is just basically the use of Backus-Naur form notations. So tokens are evaluated against BNF, and if they are found in the proper way, then they are accepted, and if they are not, then the syntax error is generated. So every single statement has to be in the form which is expected by the language. In that syntax error, there might be the part of keywords properly used and variables properly used. All right, so every single statement, when it is tokenized, it is being checked against the BNF, and all the elements should be presented there. And if there are keywords and variables, they must be present in keywords and symbol tables respectively. If they are not found, then the syntax error is generated. Describe the code generation phase of the compilation. We have covered it. And now this is October, November 2008 P3. The following rules define word in a piece of text. Letters are defined as A, B, C, D up to Z. A word is defined as a letter or letter word. Means a word may have a single letter or maybe any series of the letters. So state why hello is not a word, because this H after E, L, L, O after H, they are not present in lowercase. They are only in, had that been hello like this, there would be no problem, but over here there is a problem. Sentence is a set of words ending with a full stop. So full stop के लिए let's make a token for full stop. Let's call it full stop. Full stop is defined as, okay, so full stop or question mark. Okay, so let's call it sentence terminator. Terminator. Terminator is defined as a full stop or question mark. Okay. Sentence is a set of words ending with full stop or question mark defines sentence. Okay. Now, every word must have a space in between. So space is defined as what? Let's call it, just give it any shape. Let's make it tilde. So this is a space. All right, so space is defined as this, tilde. Okay, then let's define the combination of space and a word. Combination of word and space. So what is a word? Word is any number of letters. Combination. So let's call it combination. Combination. Combination is defined as a word and space. All right. And then let's define several words together. And this might be, let's call it set. Set would be the right word. Set is defined as a combination, means a word and space, and a word. Word, combination, word, space, and word, and that's about it. Or a combination which is going on, word and space and word and space. So this would be a set. And then what is a sentence? Sentence would be sentence is defined as a set and terminator. All right. So what is a terminator? Terminator is ending a sentence either with a full stop or question mark. What is a space? Space, since we cannot show a space, so you may take any of the character which is unusual character. You may take cap, sorry, you may take cap, you may take ampersand, you may take tilde, whatever. That is up to you. That you must take something, or sometimes you may take a space with double quotation. So that is a space. Then we have formed combination, because we understand that if there are several words, then every single word will be accompanied with a space in between. So that is what we call combination. And then we have to create a set. Combination and word means that these words will go on. After every combination, there would be a word, because if there is a word, then it can be terminated with a terminator. Or if it is ongoing thing, means word space, word space, word space. In that case, this set will go on. Okay, so combination and set will go on. But at the end of this, and at the end of any of the sentence, there is no space. So sentence is a set. Set might be a combination and word, or combination goes on. So if it is last, then it is a combination, means after last word, there would be just one terminator, and this will be terminated. So that is how you would have to actually address it. Okay, there might be changes to it, it's up to you. And there is always flexibility in such questions. तो आप लोग इसको बिल्कुल इस तरह नहीं समझिएगा कि इट इज़ फिक्स कि ये ऐसा ही होना है. एक्चुअली मार्क्स इन चीज़ों के नहीं मिलते. मार्क्स मिलेंगे कि आपने एंडिंग ऑफ द सेंटेंस को कंसीडर किया है, आपने स्पेस को कंसीडर किया है, आपने कॉम्बिनेशन को कंसीडर किया है, आपने सेंटेंस के अंदर सेट्स को कंसीडर किया है. दैट इज़ हाउ यू विल गेट मार्क्स. सो इफ़ योर अप्रोच इज़ डिफरेंट देन दिस वन, दैट इज़ फाइन. Two stages which a high-level language program undergoes during the compilation are lexical and syntax analysis. Discuss how errors are discovered during each of these two stages. So this is October-November 2009 P31. So at lexical stage, keywords errors can be found, keywords related errors, or valid variable names can be checked. So at lexical stage, keywords related errors are shown, valid variable names are checked. Variable names against the rules. All right. And then at syntax stage, tokens are checked against Backus not form notations and grammar related errors are shown. And constructs related errors are found as well. So if it is a spelling mistake, it is syntax error. If there is no end if for if, then it is construct related error. A keyword is wrongly used, then it is in lexical stage error. Variable names are not properly made, then it is lexical stage, and sometimes it is found at code generation stage as well. All right, so there would be the flexibility. Explain the difference between using a compiler and interpreter for the translation of high-level language. So, and execution, the translation of high-level language and the execution of high-level language. Interpreter translates one command and runs it before translating the next. All right. Compiler translates the whole program before it executes it. Interpreter maintains source code throughout the execution of the program. Compiler creates object code and then leaves the source code. Since object code is converted to machine code and that is executed further, and compiler no longer needed the object code or the source code itself. Compiled programs will be longer than the source code. Obviously, they are made from the object code, and we know that In high-level languages, we write less, but for assembly language object code, we write a lot. Number of instructions are enhanced. Compiled programs will tend to execute faster because they are already converted to machine form, and there is no further execution is required. That's about it. You don't have to write a lot. One phase of compilation is the code generation. Name the two phases that are carried out before the code generation: lexical analysis and syntax analysis. All right. Describe the code generation phase. So code generation phase is actually create machine code program or object code which is equivalent to the high level language program. The code which is created will not be efficient, so it will be optimized as well, and optimization happens to reduce the number of commands in the object code. An integer is defined in a certain language by the following BNF rules. So integer might be a non-zero digit and a number, or just the non-zero digit. A number is a digit or any number of the digits. Non-zero digit is starting from 0, and digit is having a 0 or any non-zero digit. Explain why each of the following is not an integer, because there is no mention of the point. And secondly, every single number has to start with a non-zero digit, and it is started with a non-zero digit. A real is defined. Real as an integer, or a zero, as an integer or a zero. So let's call it x, and then define x. X is defined as an integer or 0. A real is defined as an integer or 0 followed by a point, okay, followed by a point, followed by an unlimited number of digits including none. In unlimited number of digits means number. Including none means it might be just x followed by point, and that's about it. All right. So you may create point directly over here. You may have another element made for point as well. So we have explained x. We have number already given. Point is a constant, so integer is given, x is defined. Now we have to define 0. 0 is defined as 0. All right, so this is your answer. Draw a syntax diagram for real. You may use nz digit, point, and 0 in your diagram, but no other values. So real is defined as a non-zero digit which is actually a number. They have not allowed us to use number, so we have to make number over here. So a non-zero digit, this is integer. This is integer or 0. Integer or 0. So first we have to describe integer. Integer is non-zero digit and a number. Number is actually any combination of digits. So digit and digit can be any combination of digit. So this is basically integer. So a real is defined as an integer or zero. So this is zero. So we may go this way. All right. So this is actually integer. So a real is defined as an integer or zero followed by, so it means that followed by a point. So followed by a point by an unlimited number of digits including none. So by unlimited number of digits. So this is unlimited number of digits and this is none. All right, so that is how it will work. A real is defined as an integer. So this is actually integer because they have not allowed us to use integer in this case. So we had to actually use this integer and describe it over here this way. Integer or zero, which is followed by a point and unlimited number of digits including none. That is how you would have to actually deal with it. All right, so these are so many questions that we have solved and there are so many others left. I don't think that we would have anything different than that. These are RPN questions. So you have this file, solve it yourself for Backus-Naur form and RPN since we have covered it. So that's about it. This topic is actually 3.4.3 translation is covered and we will start with a new topic. See, we are covering every topic with its related past paper questions. We don't know what is coming up afterward, whether schools are opening or schools are not opening. I'm trying to cover every topic from every aspect, whatever, from one book, from another book, from my notes, from my knowledge. I write it, I show it, I solve past paper questions in a hope that if there would be any contingency, any issue, anything that would not let us or that will not provide us time to revise everything. So I want to complete every topic. Now you people might be procrastinating, you people might be thinking that it will take, you would have a lot of time or there would be no problem, no issue, then you will be revising. So you might be at your own afterwards. आपको जो है ना अभी से मेरे साथ सारा का सारा पढ़ लेना, ये नहीं हो कि वो आप जो है वो अभी से ढीले पड़ जाए और फिर वो ना हो सके आपसे, तो इस तरह ना कीजिएगा.